Hi everyone, and happy International Day of Human Spaceflight! 64 years ago, on the 12th of April of 1961, Yuri Gagarin became the first human to journey into space. Launching from Kazakhstan aboard the spacecraft Vostok 1, he completed a single orbit around Earth in just 108 minutes. This historic mission marked the beginning of human space exploration, and this is what we're here to celebrate today. But a lot of advancements had to be done, and there's been a lot of achievements since then. So let's talk about them. The four pioneers most commonly associated with rocket development are Tsiolkovsky, Oberth, Goddard, and von Braun. Hopefully I didn't butcher their names. Before them, the rocket already existed, but mostly as a weapon. So these men were the first to envision and test the rocket as a means to reach space. Konstantin Циолковский was a mathematics teacher who wrote about space travel, including escape velocity, in 1883. This is the velocity to escape Earth's gravity. He also wrote about artificial satellites in 1895 and a paper in 1903 deriving the famous rocket equation. In this paper, he also dealt in detail about using rocket propulsion for space travel. The rocket equation tells us how fast a rocket can go based on how much fuel it has, or how fast it is expelled. It shows us that to reach higher speeds, you either need more fuel or to expel it faster. He also wrote about multi-stage rockets in 1924. He never experimented with these principles, it was all purely theoretical, but it did award him the title of father of modern rocketry. Tsiolkovsky's German counterpart, Hermann Oberth, in 1923 turned his rejected doctoral thesis into a book, detailing the use of rockets for space travel, including designs of liquid fuel engines using alcohol and liquid oxygen. His work inspired many to create amateur rocket societies, and his book and principles were later used by von Braun, who we'll talk about later. Oberth's work was entirely theoretical like Tsiolkovsky's, but some were ready to build. Robert Goddard was a physics professor in Massachusetts who launched the first liquid-fueled rocket in 1926. It was 5 kilograms, and it was powered by liquid oxygen and petrol, reaching a height of 12.5 meters. He also developed the so-called Hoopskirt rocket, which was launched in 1928. It flew for 3.2 seconds, covering a distance of 62 meters. This is actually a reconstruction, as the flimsy structure was damaged during flight. I actually got to visit the Air and Space Museum in Washington, D.C. last year, and I took this, albeit terrible, photo of it. He was also granted several patents for liquid-fueled rocket combustion chambers and nozzles, and for other numerous inventions crucial for modern rocketry. The US government would later pay him $2 million for his patents in 1960. Unfortunately, talking about rocket history means talking about World War II. Wernher von Braun, mentioned earlier, joined military research for Nazi Germany, and he developed the A4 liquid-fueled rocket, which then became the V2 rocket, which carried the 1-ton bomb into the center of London. This was the first reproducible liquid-fueled rocket, and it combined the ideas of amateurs and dreamers, sadly, under the urgency of a military program. Once the war was over, it is well known that the Russians took the site and its contents, and the Americans brought von Braun and key members of his team to the US. After World War II, we have the Cold War, which triggered the space race between the Americans and the Russians. This brought us the first artificial satellite launched by the Russians, Sputnik 1. It had an elliptical low Earth orbit, and it sent a radio signal for about 3 weeks before it fell into the atmosphere in January of 1958. A few years after that, we had Yuri Gagarin as the first man in space in 1961, which is what we're here to celebrate today. This rushed the Americans to have a first of their own, so with von Braun as the chief architect of Saturn V, the Americans were the first to have a man on the moon with the Apollo 11 mission in 1969. In that same visit to the National Air and Space Museum, I got to see the original command module of the mission. I could almost hear the notorious words,
"It's one small step for man, one giant leap for mankind."
Now, the question is, why do we go to space, especially with such a dark history to get there? The short answer? To do something good with it. To move forward, united, not forgetting that what we've built came from a painful past. The long answer? Well, you might think that we're leaving Earth behind by exploring space, wasting money away when we have so many problems on the ground. The truth is, exploring space can help us a lot down here. If it wasn't for space exploration, we wouldn't have the satellites that provide us with GPS, weather forecast, global communications. Even the camera on your phone was improved thanks to NASA tech. But beyond that, space offers something that Earth simply can't: a clearer view of the universe. Our telescopes in orbit like Hubble and the James Webb Telescope can observe galaxies, exoplanets, black holes, and the early universe without Earth's atmosphere in the way, and get great pictures like these. We can study solar activity and how it affects our planet, monitor climate change from above, and even search for signs of life elsewhere. Microgravity research in the ISS has advanced our understanding of medicine and biology as well. Man has challenged the limits by wandering into space. Despite its unpleasant history and how we got there, today we're here to celebrate how we have turned it around. We have conquered space and done what many thought it was only possible in science fiction books. And in doing so, we've created technology, discovered new science, and developed tools that benefit life here on Earth every single day. Happy International Day of Human Spaceflight.